Hi everyone, welcome back to our YouTube channel InfinityGreedy. In our previous video, we have seen the derivation of time complexity for quicksort in best case and average case. In this video, we are going to see the derivation of time complexity of quicksort in worst case. So let's get started. So when you think there will be a worst case for a quicksort, the worst case will be when we select pivot element as the smallest or the largest element of array. For example, if you have a sorted, okay, for example, you have a sorted array. For example, you have 1, 2, 3, and 4. Now, if you consider 1 as your pivot element, I'm sorry, if you consider 1 as your pivot element, in that case, what will happen? 1 is at right position, right? So 1 will remain here. I'll just write it here. So 1 will remain here, and so whatever you will get here is you will get it, and there is nothing on the left. Now 2, 3 and 4 will be there. So again you will take second element. So 1 and 2 will remain here. Then 3 and 4 you need to talk about. So after 1 at left you have nothing. Here you will have 2 elements. So if you think if you have n elements, and if you have chosen, so at left partition you will have 0 and you have n minus 1 elements. Then in next pass you will have 0, you will have n minus 2 elements. Are you getting it? So why it is worst? The worst because, see, in divide and conquer, if you are having a problem of n size, in worst case you are able to define it by n by 2 size. So you only have to spend time for n by 2 and then it is getting further. But instead of here having size of n, you are just able to get one element sorted and n minus 1 still the problem is there. Are you understanding? So that is why it is there. Okay, I'll take one other example. If you choose the largest element, that is 5, 4, 3, 2, 1. So when you take 5 as a pivot element, so 5 will come here. So here on the left, you will have again how many elements? 4 elements left. So it is like this. At n, at left you will have n minus 1 element, but at right you will have 0. Here again at left you will have n minus 2 element and 0. So like this, you will get a skewed, what we call this as skewed recursion tree. Correct? Are you getting this? I'm writing this because it will help you for the derivations. If you understand it, we can get started with the mathematical derivation. So you will have directly got it, right? So it is something like your t of n is nothing but it is like 1 plus 2 plus 3 plus so on, n, that is n into n minus 1 by 2, that is n square, right? Directly. If you understood this, right? So at every pass you will have n, then n minus 2, then n minus 3, then n minus 3, so on, so on, till 1. So if you sum them, you will get n square asymptotically. It is n square by 2 minus n by 2, right? But if you consider asymptotically, it is n square. Remove constant, then you get n square minus n. So asymptotically, n square is the answer for the time complexity. But I'll drive it. Don't worry, okay? So in case you are having crunch of time, you can do this way. You can write this tree and then you can write t of n like this. But I am going to drive mathematically because for all best average case, I have derived it mathematically. Okay. So let's roll up the sleeves. So don't you think this Tn is nothing but it is Tn minus 1 multiplied by n into constant? Okay. So same way we have done it, right? For the best case, Tn was 2t n by 2 plus n into constant. I have removed the constant because constant has no value. So I'm just writing a constant here just for you, but in the end of the problem, I will just neglect constant. Okay. So this is what we have written. So I told you that this n is for the minimum number comparison, same, and 2t because we are dividing array into two equal parts with equal number of elements in best case. But here we are just getting the array of n minus 1 subarray, element subarray. Are you getting it? If we have n elements, in the next iteration I am getting n minus 1 element subarray, right? Whether in the best case, if n element, I was getting n by 2. Correct? So let's write it. So at t are n minus 1 plus n into constant. Now you put, instead of this, you put n minus 2. What you will get? You will get t n minus 2 plus n minus 1 into constant plus n into constant. Now you put t of n minus 3. So when you put t of n minus 3, what you will get? T of n minus 3. See, you put here. Instead of n, you put n minus 2. Then instead of n, you put n minus 2. So you will calculate this by this. So t n minus 3 plus 3 into n into constant minus 2 constant minus constant. Why I got it? Because from the above example, Tn minus 2 is nothing but 2 into n into constant minus constant. So now you might have got the terms. So if you do, can I write T n minus k plus 2 into n into constant, 3 into n into constant. Can I write k into n into constant? And then now 2, 1. If it is was 1, it is 1, 2, 1. So next will be 3, 2, 1. Then 4, 3, 2, 1. Like this it will come, right? So what I'll do, I'll write that minus k minus 1 into constant. So on, so on, so on, so on, so on. At the end, minus constant. This is minus. Okay. Minus constant. So if you rationalize this, you get t n minus k plus k into n into constant minus constant. If you take common, you get k into k minus 1 by k into k minus 1 by 2. Are you getting it? How I got this, and from this how I got this? It is nothing but, if you see, it was like 0 constant. In second it came as 1 constant. In third iteration it came as 1 and 2. So in third it will come 1, that is 3 constant minus 2 constant minus 3 constant, like this. Correct? So in this case, let's assume k equal to n. If you assume k equal to n, what you will get? You will get n minus n plus n into constant minus constant k, that is n into n minus 1 by 2. So from this, what you will get? T of n, T of 0. T of 0 is 0. If you don't have any element, you don't need any time. So you get n square constant minus n square minus n by 2 constant. Right? If you solve this, it becomes n square constant minus n square by 2 constant plus n constant. Correct? So if you remove constant, if you do this way, so do you think it is written as n square by 2 constant plus n constant? So neglect what? Constant, you get n square plus n. So asymptotically, you get n square. So therefore, time complexity of of quick sort in worst case is n square. Are you getting it? This is easier. This is easy to understand when you actually get this example, right? that if you have a problem of n, in worst case you will have n minus 1 elements at one of the sites. So you are not able to reduce the problem to a good extent. That's why it's a worst case, right? So you can show it by the tree method also, or you can show by this method. So it is easy. Only catch is you need to assume k equals to n here, right? So if you like our video, please do like, share and subscribe. In our next video, we are going to talk about space complexity for the quicksort. Thank you.